Hi everyone, good afternoon. My name is Prakash Chandra Patil, founder of Nervi Software. I have experience of around 20 plus years in software industry. Just I would like to give the brief knowledge about the software testing, how actually it works in the corporate industry, and what exactly we do as part of software testing when it comes to the application testing. Today we are here to understand about the software testing, what is quality, and what are the different life cycles we use when it comes to actual working situations in the IT industry. Here, first we look after the term called software testing. Software testing, it consists of many things inside. When we say testing means the quality matters. What is quality? Many of you know in your day-to-day life, you are covering or purchasing anything. Whenever you go out, you will test the quality of a product. What do you mean by quality? Quality is, in general, it is a fitness for the purpose. What we call it as fitness for purpose. Fitness for purpose is quality in general. I hope you are able to see it. In general, it is this, and when it comes to a software, first of all, you guys need to understand what is software. As per me, the software is a collection of logics bundled under a particular framework to achieve the end result. Mean to say, it has certain set of logics written using any programming language. Logics. It's not working. Logic plus certain set of files. At the end, the intent is to achieve the result. What is the result? Result is a solution to the problem. That is why the software play a vital role in addressing the concerns of the customer with respect to their problems. Assume there is a particular school running with 10,000 of students where we cannot take the manual attendance for the students on daily basis. So, in such situations, there is a need of software. That software will automate certain set of process which is complicated to address on day-to-day basis. That is why the software play a vital role in every business which needs a lot of transactions in day-to-day life. That is why people go for a software usage where we automate certain complex situations and it will be accurate and it helps you to run all time whenever it is required. Hence, as per the software, the quality means meeting the customer expectations. Meeting the customer expectation is called software here. Meeting the customer expectations is called the software quality. So, when it comes to a quality, everyone needs a quality, no one will compromise on the quality. Hence, the quality meeting the customer requirement. There are certain set of customers. As you know, in the market, there are thousands of domains. When it comes to domains, logistic domain, education domain, healthcare domain, and warehousing domain, warehouse automation, all those things are considered as a domains. Okay. So, moving on to the quality and the software, you got to know a little bit about quality. That is a fitness for the purpose or meeting the customer requirement is a quality. What is software? Software is a bunch of logics bundled under a particular framework to achieve the end result which is expected by the customer is called as software. We may use any programming language, it may be C++, .NET, Python, anything. Like that, we have many programming languages to create a software. Coming to the next point, what is the software? We have covered that. Now, what does the software consist of? There are three different layers in a software. I hope every computer science engineer understand what I'm talking about. Is the first layer, what you see in front is the graphical user interface, where you can act upon it. That is called GUI, or a graphical user interface. This GUI is linked to another layer called logical layer. That is what I am talking about. Actual software functionalities are deployed or implemented using a different programming languages. It has a logics, it has a DLL, it has many things which will make the UI to work. UI is kind of a dummy layer if you do not have a logical layer attached to it. This logical layer works based on the action you perform on the interface. Assume that everyone is aware that Google, right? And when it comes to Google, we have a emailing software called Gmail. In that Gmail, you see a user interface, username and the password, then login button. If I give you the dummy interface which has only these three fields, if you click on anything, it will not navigate to the next page. That means it is not linked to a logical layer. When you click on login button, it will take you to the home page, or where you can see the inbox of your email. That is how it is logically linked UI with a logical layer. Then you are trying to send an email to a particular recipient, then you will enter his email ID, subject and the body of the email, and you click on a send button. This is called a functionality. Send email is a functionality. Just try to remember the term functionality. Functionality means there is a certain set of instruction and there are certain steps of what is the steps we need to follow to complete one functionality. Sending email is a one functionality. That is called as a software includes many functionalities, like 1,000 functionalities in one software might be possible. That is why the software has a GUI followed by the logical layer. Logical layer is the programming what you write here. Then all these transactions, you do it today, you do it tomorrow, you do it for a year, but everything need to be stored somewhere. Tomorrow I might forgot my password of a Gmail account. Then what I do, I will click on a link called forget password. Forget password will retrieve the data from the backend. Backend we call it as a database. Database is a backend. You can create a SQL database, you can have Oracle database, you can have MySQL, you can have many MongoDB as well. There are different set of backend softwares are also there to help you to create application. Software application has three layers. One is GUI, another is logical layer, another is a backend layer or database we can call it as. You understood the GUI, logical layer and the backend part, it is called as a database. So all these are kind of a different layers what you see in the sandwich, right? The top layer bread, inside there is some sabzi is filled, there is another bottom layer, another bread piece. Same as the software is also a kind of a sandwich where all these three layers are linked together to get the required output. How do you feel that the software has what is required for me? All those things are achieved in the form of different functionalities. I hope you all are aware about the different softwares. One is web application, another is a client application. Web plus desktop we call it as, okay, desktop application. What is the difference between the web application and a desktop application? Web application, it needs an internet to operate. In simple words, web application can be logged in from anywhere. If you have a laptop with you, if you have a browser, then we will give you the required URL to operate, right? Whenever you say URL, any idea what is URL? It is Uniform Resource Locator. That means this web application is hosted somewhere, not in your laptop. Assume that the Google company has a different set of servers. These web applications are hosted in the Google company server. From there, they will publish a URL, gmail.com, googlemeet.com. These are all the different URLs what we are getting from the Google. That means this web application is hosted in the Google server, and the address what you are getting is the uniform resource locator. It is locating that particular resource using a unique link that is called as a URL. That is how the web application works. When it comes to a desktop application, it is the Word application or a Excel application or a PowerPoint. These are all called as a desktop application. Okay, PPT, Word, Excel, or you can say MS Office. That's it. All together we call it as one bundle called MS Office. Right? All this together we call it as Microsoft Office. But when it comes to a different application, these applications you need to install on your own laptop. That means it has the client and the database both in one. Whereas here you are connecting to a web application through a client called browser. Without internet, this will not work. Right? Without browser and without internet web application will not work. But this doesn't need anything. This itself acts as a client as well as the database. Hence it is called as a desktop application or a client based application. I hope I am clear. We have spoken till now about the quality, what is the software, what does the software consist of, and what are the two different types of software we have at current. And we do have the mobile applications that comes under a different architecture. But when we are talking about the applications, usually we talk about the web application and the desktop application. Some companies will also work on the mobile application testing. That is also same, only the resolution testing and testing on a different OS we do as part of software testing. But traditional approach of software testing is majorly to test the web application and the desktop application. I hope it is clear. If you guys have any questions, please feel free to put a comment there. We'll go through those and try to understand that. Okay, coming to the next thing, because we are talking about the software testing, we have spoken about the software, the quality, and we have to talk more about the testing. It is a detailed point where some basics we need to understand before we switch on to that particular topic. So what we have to do to understand, you connect yourself to the real-time world. Whenever I say testing, testing is verifying or you are validating. Validation everyone will not do, but verification everyone will do in their day-to-day life. Even if you go for buying a particular t-shirt, we will test ourselves, even though company tested and they put the mark as QC OK, right? QC OK means it is tested, it is developed, mean to say first designed, developed and tested, then released to the market. Despite of that, we do our testing. Is the color is good? Is that particular t-shirt suits for me with respect to the size? And what is the quality of the cloth? All those things we usually do whenever you go for purchasing anything. So this is called as in testing. One part of testing is verification. Is it meeting my requirement? I am buying this particular product. Does this product meets at least my requirement? I have to wear this particular t-shirt for a sports, or this particular t-shirt for a ethnic wear or a programs, anything. That kind of t-shirts you are going to choose. That type of the cloth differs, but the company remains same, the size remains same, or the colors will vary based on your requirement. We do produce everything in a lot. So company will not inspect each and every product. We will take certain things randomly and we verify. One lot might consist of thousands of t-shirts, where the particular operator has certain amount of time given to him. This lot should be finished within an hour. Then he randomly picks certain set of products and he verify and put the seal as QC OK. But final lot, someone will automatically put the QC OK product. That means random testing is happening. Everything cannot be tested. The mindset what I bring I want to bring it here is you cannot test everything. Everything cannot be tested. Hence, so we have a part called software testing. Even the software, as I said, it has lakhs of lines of codes written by a different developers, not written by one developer. So, what is software is? Software, it has a particular unit. It has a unit developed by one particular developer. Say unit 1 is developed by X person, unit 2 is developed by Y. These two units together forms a module. Unit, what happens here, whenever I go to a customer, I'll express my problem. Our business analyst of the organization will write all his problems into a document called requirement document. Okay, software requirement document. SW means software requirement document. He will write everything, whatever. Assume that this X person come to me and expressing his problem. I have an organization, I am facing so and so problem. I need a solution for this particular thing. At that time, I will go through the software requirement document. I analyze. Then we will give this particular document to a software testing team as well as the development team. Both will go through, analyze. We try to make sure whatever the understanding we gain from this document is right. We will again have a meeting with the BA. BA is nothing but business analyst. This guy will collect the requirement from the customer. Hence, we go through the document, we analyze the document, we will go with a certain set of clarification. I am not able to understand this particular requirement which is of number 10. So make it clear. This is what is my understanding, is it right? Kind of discussion we have with the BA. BA, if we say yes, this is right, then the developer will go ahead and write the code to implement that logic, right? He may use, as I said, programming language .NET. Somebody might use C#, right? Like this, different users or a different programmer, they will use particular set of programming language, but you cannot use more than two. Okay, .NET followed by the SQL, C# followed by the Oracle. All those things will be decided by the one person called architect. He will be paid highest in the software industry. Architect will take decision which programming language is used to use and which is the database we are trying to use, what are the different types of logics we are using, how comfortable. We do a tool analysis itself, which programming tool or which programming language we need to use. And those all things discussed in the architect meeting, and we finalize this is what the tool we would like to use, Eclipse for Java, C#, .NET, another studios we want to use, and we will also finalize what kind of database we are going to use. Okay, so assume that X developer has developed the unit 1, Y developer has developed the unit 2. When I am testing the unit 1 has just the logic of login, it is working fine. Then unit 2 has just a simple logic of navigating. After clicking on the login button, it take you to the inbox of your Gmail. These are the two different units developed by two different developers. So when X tested, things are working fine. Hence he has checked in his code to the central database, central repository. Unit 2, yes, when I ask the developer, things are working fine. Both we have clubbed it together now. Okay, we formed a module called login. Login module is ready with a check-in of developer X and developer Y. Both have written a different logics as per their understanding and the requirement. Now we have clubbed this and created one module called as a login module. Okay. Then the problem occurs when these two are independent. It is working fine. That we call it as a unit testing. We have done a unit testing. Developer says that I did the unit testing, and the result is pass. X and Y both said this. We integrated as a one module Then we do integration testing. Integration testing of this particular module. What is integration? We have integrated two units together as one module, and now we are checking the behavior of unit 1 and unit 2. When I tested it independently, both the units are working fine, but when I come, this is the next phase. Your units will not be delivered to the customer. Units has to integrate with the next unit, which is interlinked. So I integrated. We have started testing the integration testing. Integrated two modules. What happens? Here we are given a certain space in terms of MB. This code should set in this particular memory itself. This code should set in this particular memory itself. There is a memory leakage. Now excess space has been occupied, or there is a overlapping of the controls. I hope you guys understand what is controls is. There is a text box to enter your username. There is a text box to enter your password, and there is a button called login. It is overlapped on the password field. That means your unit which is developed is failing at an integration testing level. You understood two things now. One is unit testing. Unit testing is nothing but the code developed by the developer. He will test on his own, on her own, by giving the different inputs. It is working fine. Then we have integrated both the set of codes as a one module. We call it as a module testing or integration testing of units. At an integration testing, it is failing because the controls are overlapped. Even if you click on login button, it is not taking you to the inbox of your Gmail. Or when you click on a cancel button, it is taking you to the login page. This is what we call it as a deviation between the actual and expectation. When I cancel, what should happen? It should reset the username and password field, but it is logging in. When I click on login, nothing is happening. So this is the we call here as a defect. The defect is nothing but we have given a EPIC software requirement document which says that when you click on a login button, it should take the user to the inbox of your Gmail, but it is not happening. When you click on login, it is unresponsive, not at all responding. When I click on cancel, it is logging in. That means the interchange of functionality happened. And these kinds of defects we usually see in the integration testing. In the interview, people will ask you, what are the integration testing defects you found? Overlapping of a control, memory leakage, interchange of functionalities. These are the three different bugs what we find during our integration testing. Okay, moving on to the next level. We have spoken about how the software is developed. First, we have a requirement document. Requirements will be assigned to a particular developer. He will develop his unit 1, unit 2, unit 3 like this. Thousands of units are developed. Based on the relational logic, we develop module 1, module 2, module 3 like this. And all these three together we call it as a subsystem. That means 50% of my system is ready. Unit clubbed into a modules, modules clubbed into a subsystem, subsystems together forms a system. Many subsystems together forms subsystem or application, complete application. I hope I am clear. We have spoken about the requirement document. This requirement document will have thousands of requirements given by the customer to us. We analyze those documents, we create a units based on the logics. We club these units into a modules. These modules together we form a subsystem. Subsystem together forms a system. This is the complete application development cycle what we follow in the industry. Okay, moving on. As we have spoken about two important terms, we have spoken already about quality. You know that. Under this quality, we have a testing. This testing will be done in two ways. One is verification, another is validation. Whenever people ask you what is testing, many people will say that tester will test the application and finally he reports a bug or a defect. But yes, ultimate the goal is that think logically. When a developer working on certain set of things, it cannot be delivered directly to a tester. At that time, what does the testing team do? No company will pay you without doing anything, right? So there are two methods of testing your software. When a developer is doing a coding and nothing is delivered to QA, I cannot test anything. But both of us has a software requirement document, SRD, or a business requirement document. For document people will not say SRS, you can say software requirement specifications. Okay? This document is given to both of us, QA and testing team. During the development, when the development is doing the coding part, we cannot test their code because they have not delivered anything to the QA team, and hence we will be involved in the verification. What is verification? Simple example, verification is nothing but some companies or some authors have written, are we doing it right? We are verifying, are we doing it right? Yes, one way it is right. But when it comes to actual industry definition, it is called as a static testing. Static and dynamic. When I say dynamic, the code is involved in testing. When I say static testing, it is no code is involved in testing. I have a certain set of document. I am going through the document. I am making myself understanding, analyzing the requirements of the business. Then there are certain set of documents created to develop our application. It may be a design document, design doc. It has, as you know, that computer science students, flowcharts, ERD diagram, and activity diagrams. Many diagrams will be there as part of your design doc. Flowcharts, you are aware of it. ERD is entity relationship diagram. Activity diagrams, entity relationship diagram, activity diagrams. It's all there as part of your design doc. We go through the design doc and we review the document, not the code again. Hence, we are calling it as a verification. Verification is nothing but a static. Nothing is dynamic here. Static and validation is dynamic. If you remember this word also, you will be able to recall something in your interview. What is verification, validation? Verification is a static activity where we validate or we review the design documents, the requirement documents, or the documents created by any stakeholders. So we will review those and we find a mistakes or a bug in it or a defects in it. Hence we call it as a verification testing. Validation testing can be done only when, as I said, unit plus module plus subsystem plus system, right? This formula together they may deliver a module as a build. Again question comes, what is build? Or some company will call it as promote. It's a development job to give you something for the testing. As you all are aware, you use Play Store to get any new application installed in your mobile. The same way, I do need the application exe, which can be deployable, which can be installable. Such things will be delivered by the development team to the QA. First thing, I will ask you, when are you giving me the build to test? The development says that I will be giving you a build in coming Monday. We go to that location, we verify, does that location has a new promote or a build deployed there? Yes, if it has a build, then what I do, I take that. Same way as you go through the Play Store, search for the application you need, you install it, right? The same way I go to that server, I copy that build to a test server. Server and other things you have to understand because you are all from computer background. Server is nothing but a computer which has a special ability to interact with the different customers. It has a parallel threads capacities. responding to a parallel app in request comes to a different clients, right? So that server we will deploy our promote, whatever they are given, we are going to install in a test server. This is called as a test environment. Test environment. This we will not be giving it to anybody for use. As long as QA says that everything is working fine, then only I will deliver this particular build to the next level, to the next level of testing. Okay, so you got the term build. Build is very important term to understand, because most of the people do not understand the corporate used terminologies. Software testing, people think that software testing is nothing but a process where we test the application with the intent of finding a bugs in it. This is the definition. But they never says that. All these things are covered as part of it. Build. If you do not know what to ask to a development team, how can we test? So that is a common criteria. You should understand the basic functionalities, basic terminologies. What is build, what is quality, what is testing, what is verification, what is validation, what is dynamic testing, what is static testing. All those things play a vital role to improve your understanding of the software testing. These are not part of a particular topic what we are covering today, but these are the basics. If you do not understand this, you will not be able to understand anything in the upcoming classes. So build is a set of instructions, set of files, set of logics grouped together and created a one executable file. If you do not remember everything, it's fine. Just remember it is an executable file given by the development to a QA for the testing. It has set of logics, set of DLL files, everything, whatever is required for it to make it execute is nothing but .exe file. If you remember .exe, we take that promote, deploy it in the test server, then we start our testing. That is called a dynamic testing. This is called, all this process what we refer here as validation. That means we are actually deploying the code developed by the developer in a test end server, and we are starting the testing where the code execution is happening at the back end. Right here, nothing. This is called document testing. What we are testing here is supporting document. What are the supporting documents? SRS, software requirement specification document, design documents, which may be a different flow chart, it may be entity relationship diagram, activity diagram. All those things we verify. Is these diagrams are developed as per the requirements or not? Is it deviating from the what is expected? There also we can find a bug. That is called early stage of testing. Nothing is ready, still we are finding a bug. When you see as an outsider, it looks like a magic. But when it comes to the real world, we have a set of documents shared into a SharePoint where it is accessible for all. I can download and go through that particular document and identify whether this software requirement specification is matching with the design document. If not, I will contact the design architect saying that the logic or the requirement what it says is different, what you have written is totally different. So it is a deviation between what is expected and what is there in the document. That is called as a verification testing. Verification testing does not involve any code, it involves the testing of supporting documents required for the application development, whereas the validation is a testing activity where we deploy actual code into the test environment and we start interacting with the code by performing a different actions. Login we do, we'll send a mail, we'll check that it has listed into the sent email, whether the recipient received or not, the success message also we verify. That is called as a verification. Now the question comes, what is software testing? As per the traditional definition, software testing is a process of testing the application under test to find out the bug with the intent of finding a bugs in it, right? Now the definition, real definition is testing is a phenomenon which will include two set of activities, which is verification and validation, to make sure the given application works as per the customer expectation, is called testing. If there is any deviation, then we report a defect. I will come to that. What is defect, what is bug, what is error, what is exception, all things are different. Okay. I hope if you guys have any questions, any comments from online, please let us know. We'll go through that as well. Fast or the pace is okay, do let me know so that we can shift to your level as well. Okay, now we got to know many things. Quality, software, types of SW, types of software. Then we got to know what is testing. In that itself we got to know verification. These are very important. Every interview will ask you what is verification, what is validation. Even though you have different set of levels of experience, the questions are common. Verification, validation, build, then what is, I hope that we have covered all of these things, right? As of now, quality, software, types of software, testing, verification, validation, and then build are a system. And we also covered unit, modules, module, etc. Okay. So after getting to know all these things, the next thing is very important. We will cover all these things again in our detailed session, but I am making you all understand exactly what we do in a software testing. So we all have a common cycles. I hope it's not visible. First one is software development life cycle. Software development life cycle. Second one is software testing life cycle. SW means software testing life cycle. And we do follow one common life cycle between both of them is bug life cycle. Okay, these three are very important. I can give you an instance where software development life cycle in one of the interview in one organization, he was having so depth knowledge. This question has been asked to him, could you please briefly explain what is software development life cycle? That person who was having around 12 years of experience, he started explaining the life cycle. The interviewer got impressed the knowledge what he has. Then that particular session or answer is what is podcasted to all the employees of that particular organization. That means why I am telling this is the depth, the way you have to understand this particular life cycle is much more important whether you go to a software development or software testing, it doesn't matter. But the complete understanding of the software development life cycle is much more important. When you move or you started working on a software testing, this play a vital role, software testing life cycle. But BLC is common to both of us because it is a shared life cycle between software development as well as the software testing. I will talk about brief, but as I told you, the depth can take you. That person has explained around 8 hours continuously about software development life cycle, not even single minute break. Everyone got impressed the way he expressed. They are able to see the real picture in front, kind of explanation what he has given. So software development life cycle is a kind of continuous learning. It cannot be ended anywhere because many innovations will come, many technologies will change, many methods will get into. So the basics what we are going to cover as part of this is what are the different phases it has, right? I hope this is covered in your software engineering, right? So first of all, we do have a requirement analysis phase, right? It is called as in gathering also, requirement gathering. Then it will get into a design. In design itself, we have two phases. This design is divided into two phases: high level design and low level design. Okay. After the design, we get into a coding. Coding is the actual development where it happens. After that, our testing falls here. Testing. After this, maintenance, deployment and maintenance. Deploy and maintain. I hope it's not visible. Requirement gathering and analysis phase, where the business analyst play a vital role, collecting the requirement from customer. Then the design phase, where the design architect and DBA will play a vital role. Just I am writing their roles here, who will be very important person in which phase. This particular things will not be covered in any of the other things. Okay. Design phase, BA means business analyst. He will interact with the customer and collect the requirement. That's what it is. In the design phase, here the architect. Okay, here the database administrator, DBA. In the design, both will work together. The architect and the DBA together decides many things. I will talk about those. In the coding, the development team will take care. Testing, QA team will take care. This will take care by QA plus support. We do deploy the final build into a customer environment. We do perform lots of testing. Once it is stable, then we'll hand over to the support team of the organization. I hope the requirement gathering is an important phase where the BA will interact with the customer, collect his requirements step by step. He will have around 2-3 weeks of meeting with him to understand what is his expectation, right? So BA, you have to remember, BA is a business analyst, will give you the requirement. What he do, he will have the meetings with customer. Meeting with customer. Meeting plus customer is what I am writing. This is the duty of BA. Every day he will interact with your customer. He will continuously meet, understand what is the requirement, what is the problem you are facing, what is the solution you are expecting from us. The customer will have a meeting, BA will keep collecting the notes kind of thing, okay? He will keep collecting the notes. At the end of the day, his duty is to create a SRS document. If anybody asks you what BA will do, business analyst will interact with the customer and he will collect all the requirements at a minute level, from high level to minute level. Everything he will write down in a document. He will take the notes when he is interacting with the customer, but at the end of the day, he has to add all his needs into a requirement document. That is called as a software requirement specification document. This will be finalized after having all the meetings with the customer, and customer says that, yeah, I am good with this. This document will send back to a customer again for the review. Once he approve the SRS document and along with the budget, then we'll say announce we received a project. The customer has to review SRS document. He has to approve from the concerned authority along with the budget what we have defined. Then only we announce in our organization saying that we have received a new project. Till that time, we will not talk about this. Once the SRS is finalized, budget is approved, then our hiring starts. Okay, these things at a high level you should know if you do not know in depth, because it will give you the clear idea of how the hiring works in the organization also. Right? This document is approved, budget is also approved. Why we go for a hiring? Customer is expecting, I don't want the application to be developed on C# or a .NET. I want Java. At that time, I do not have a skill set in my organization who can work on Java and develop an application. At that time, this budget includes that as well. 2 resources of Java I am hiring. I do not have the architect for the same. 1 architect I am hiring. I do not have the QA team which we can test with these particular new technologies. I may need to hire few more QAs as well. All those things are added and created a budget for it. This is the timeline. These are the requirements. These many resources are required. Hence, this is the project budget. You approve it, we will proceed. Then we started hiring. Parallelly, the HR department will take care of hiring along with the certain resources. If it is a requirement for the development manager, development lead will interact with the interview candidate. If it is for a QA manager, QA leads will take the interview. The hiring will happen parallelly. We don't want to wait there. And at the same time, with the existing resource, we start our requirement analysis. We do go through with all the documents, we understand everything, and we'll come to a common conclusion. This is what is our understanding. We'll interact every day with the BA to make sure our understanding is as per the customer expectation. Thereafter, once requirement gathering analysis done, Dev QA will have a meeting together. That is called project kickoff meeting. Project kickoff meeting. These terms are important because when you go to a IT industry, they commonly use these terms. When you join without having any experience, you feel that what is this meeting is all about. So you have to understand there will be a development team, QA team along with the BA. We will all the stakeholders along with customer also. We kick off this. We'll say that this is what is our understanding. This is what we are developing. This is the timeline what we are committed. This is the budget what we are committed. These many resources will work on these projects. No change further. Okay. That all agreement will create as part of this meeting, and we'll get the approval from the customer saying that he is okay with it. So that is where we have decided the release date. Right? People will struggle. I have a release. I have a release. This is what is the release date. We have done the effort estimation. We have done the cost estimation. We know the developer needs this many days to develop this code. Right? We call it as a PD, percentage. In the IT industry, every estimation happens based on the percentage. How many percentage do you need to create this particular logic or to develop this module? We will interact with the developer. Then we will ask the testing team how many days do you need to test this particular module. All these things together we will come to the conclusion. This is the release date. Finally, we are able to release your software on this day. We commit to it. If you do not release, they will ask the reverse question saying, if you do not release the software on time, what is our action? We will say that the penalty clauses are applicable. If you delay your software delivery by 1 week, you will be charged this much. If you delay 2 weeks, this is the charge. That is where the company goes in loss. If you deliver things on time, the company will be in profit. If you delay it, that losses you have to bear with it. Right? So that is why in the software industry there is a software release. Everyone will be available, whether it's a weekdays, weekend, everyone has to work and make sure the release is successful. Otherwise, it seems like this company is not meeting the customer expectation as per the delivery dates. We have done everything, development, testing, but some reason we are not able to deliver on time. That will create a bad reputation about that company. Hence, release should be done on time. Requirement gathering you got to know at a high level. BA will interact with the customer, collect all his problems, and create one document called software requirement specification document. That is the base for further movement. Understood? What is the outcome of this is SRS. SRS means software requirement specification. Then this will be sent to design team, coding team, testing team, everyone. This is what we have received. Okay? Then everyone will go through, understand your scope of testing, what can be tested, what cannot be tested. Some features are there we cannot test, some features are there we can test, but it takes more time. Like simple example, customer told me I may use any type of username. I am not giving you any format. I may use any type of username. That means I have to test this particular login functionality with thousands of users, different types of users. Assume that I may test with XYZ at so and so. I may test with X12 at so and so. Like this, many permutation combination, 1000 times I have to test only the login to make sure it works with a different set of usernames, right? So understand the complexity. Only login, 1000 users, 1000 times I have to test. That way we will estimate. We consider all these things as part of your estimation. I will say yes, login testing itself is taking 2 weeks of time. So remaining functionalities are around thousands of functionalities I have to test. If you consider at least 1 day per functionality, it will be 1000 days. So after this, we got a one output. Every phase means try to understand there is a start and end. Start is interacting with the customer, creating a document, getting it reviewed and getting it approved. That is done. This is baseline SRS we call it as. What do you mean by baseline? Baseline means it has undergone multiple changes. Further changes are not allowed. That is called baseline the document. It is approved. If you want any change from the same customer, I have to charge him more. If we bring it at this phase, if we say at this phase we will not be entertaining any changes, the testing stage, right? So we'll talk about different development life cycles also, okay, later. Requirement gathering is the important phase. BA will play a vital role interacting with the customer, creating a software, requirement specification document and getting it approved from the customer, and thereon it will be flowing to the next departments. That means business team will create a document and send it to the design team. Design team will also review. They has two areas where two people will be working. One is software architect, another is software database administrator. These two people, as per my opinion, they are the highest paid software engineers in the industry, because this design and this database, whatever they have developed, will stay long with the customer, and they has to foresee what else might come in. Currently customer is saying 10,000 of student entries are fine, but we do consider 10% of increase every year. This software we are committing him and giving a warranty of 20 years. As per that I have to build my database as well. It should have minimum 1 lakh storage entries of students per annum. Based on that I will build my database capacity. And architect, he cannot think of what the way you think. Oh, this logic will help me. This logic, how consistently it works and what is the impact it creates in the backend. Does it create a lot of memory leakage? Does it create lots of log file which is consuming my memory? All those things he will verify. What is the technologies we have to use? What are the tools we are going to use? And what type of framework we are designing. Means architect, did you got it right? Technology, tools and the framework. Framework means, in general, framework is the set of guidelines or a structure. Everything should fall in that framework. That is what we call it as. Majorly the architect work on the technology we use, tools we use and the framework design. This design part will play a vital role because he has to foresee what is the feature of this software, how the customer will use our software. All those things he will consider and come up with a design document. Now SRS was only a text document. It might be of 1000 pages, it might be a 500 pages. It is very difficult for us to go through, right? Thousands pages of text document. It is like a reading a novel or a reading a book. It is highly, most probably we skip something. That is the reason why we refer the design document. Design document is a pictorial representation of the text document what we have. That text document is converted into a pictorial representation in the form of ERD diagrams, in the form of activity diagrams, in the form of flowcharts, so that it will give us a clear idea what is the flow. If I do these changes, where it has to go. If it is yes, it has to go. If it is no, it has to go here. Like decision making will be there in that particular set of documents. But here it is a plain text. Customer expect login should be successful. After login, the customer expect it should have an inbox where the user should get his emails. It should have a compose functionality where user should be able to compose his mail and send it to a particular recipient. This is the SRS document. Whereas the design document will give you the complete flow chart of each and every functionalities. If it is complex, they will create a different diagrams for that to make you understand. If developer understands better, then only he can code it better, and it will have a very less number of bugs. Otherwise, the system will have complete bugs only. What is bug or what is the defect? It's a deviation between the requirement given by the customer and the actual what we are seeing in the application. Customer expects when I click on login, it should go to the home page, but it is not logging in. That is the defect, right? So design architect will decide upon the technology, what are the programming languages we have to use, what is the database we are going to use, how many tables this particular database should have, and what is the upper limit and lower limit of the data storage. And he will also decide about a field level, right? This particular username field should accept how many characters, what all the characters it is allowed. Special characters are allowed, numericals are allowed, alphabets are allowed. Based on that, he has to put some validation on the fields as well. You might be aware that SQL has a field validations, right? If he gives this wrong entry, it should not accept. Like that, field validation level also he will define what type of error it has to throw, what is the restriction. Then moving on to the DBA. DBA, as I said, he is the person who will decide what is the table name, how many tables should be there, what it should include. If it is user related, user table should have this data. If it is a password related, password table should have all these details. All those things will be decided by the database administrator. You try to remember, design phase is nothing but the conversion of a text document into a pictorial document, which will make the remaining departments to understand the customer requirements, right? It has flowcharts, entity relationship diagram, activity diagrams, many things. So with this, the brief of this is over. Then we move to the coding document. Coding document, what is the here? Design doc is the output. First phase, starting customer interaction, coming out with the SRS document, that is baseline or finalized. Here, the finalized design document is the outcome. This finalized design document plus SRS, we refer both for the coding. Coding part is nothing but development team. We are giving it to the development team, go through these documents, and we will assign this particular set of these first 5 requirements. This particular development X will take care. The remaining 5 requirements Y will take care. Like this, we distribute the requirements to a developer team. They will start working on those. They will not be going through each and everything, because this deliverable is fixed, only 5 requirements out of 50. 10 developers are working. They are not even bothered about what other developers are doing and how that their code is linked to our code. We have clearly told dev manager assign me these 5 requirements, let me work on those 5. They will put their effort only in understanding those 5 requirements. Okay. Later, when coding starts, that guy will be keep working into giving a solution. Solutions, what he do is, he will take the problem statement, divide into smaller segments. Every problem should be divided into a smaller segment. Reason is, you will get a solutions for each minor issues. You will club that minor solutions into one bigger or a broader solution. that will create your unit. Okay, the coding part, the developer will understand, go through the design document, he will make his logic. His logic will be reviewed again by the architect. You might have written a logic, it looks good for you, but when I look at a longer perspective, whether this logic works in different scenarios, that validation, that review we do together. I hope this logic is good, but it is not going to last for a long time because it is creating lot of log files, or it might get into the infinite loop later. In order to avoid that, if it is a very complex requirement to address, then we give them a pseudocode also. Pseudocode is nothing but a logic, a rough logic what we have given to you. You go through this pseudocode, try to come up with a different logic. So based on that, the interaction will continuously happen with the architect, dev team, and they understand, they will develop based on the defined programming language. They cannot use whatever they want. They have to work on Java, means Java only should be used. Okay, like that, development team will develop, come up with the units, modules, and a subsystem. What happens? They cannot deliver units to a QA team. They cannot deliver the modules to a QA team. Sometime, okay, sometime they can, but units we cannot do. So development team will do a unit testing, and they will develop modules of software, right? They will do a unit testing, and they have to develop the modules. Those modules can be delivered to QA. QA will have 3 references now: SRS, design doc, plus modules are a build. We have everything now, right? When you go down in the phases, we'll accumulate with the many information. So we have all the things reference, and if I feel that there is an error, then I will refer SRS. If there is nothing is a problem, I will go as per the design document. So testing team will validate and verify the requirements against the given SRS document. What we do as a QA, we develop test scenarios. Test scenarios will be converted into test case. Test case execution will lead to bugs. Now question comes, the real chapter of software testing. What is the test scenario? What is the test case? What is the bugs, right? So what we do is, after understanding the customer requirement, we will say, I can test this. Test scenario is nothing but the high level description which is documented, saying what I can test, what can be tested. What can be tested is test scenario. Assume that login, I will test a login with a valid username. I will test a login with an invalid username. I will test a login with the alphabet plus numerical combination. I will test a login with a special character combinations. These are all the different things I can test. These are called test scenarios. Understood? At a high level, I am telling, based on this requirement, these are the test scenarios, what I am going to test. But how I am going to test, all those things are not defined as part of your test scenario. What I am going to test is defined. How I am going to test, what I am going to test, what is the expected result, we are going to cover as part of your test case. Understood, right? Login with an invalid username. This is a scenario. Now I have to convert this into a test case. First I will say, launch the browser, enter the given URL, make sure the login page is displayed, enter the username with the so and so characters, special character plus alphanumerical, and enter the password, click on login, login should be successful. This is the test case. Whereas test scenario, test the login with a special character numerical combination. That is a high level description of what I am going to test. This is a detailed description of what I am going to test, how I am going to test, and what is expected out of this testing. That is a test case. Because this will become a Bible for all of us, because that anybody can test, because it includes each and every step. Even the newcomer to my team, if he go through the test cases, if he understand the step, he can easily execute the test case. Then I will tell, this is the expected result. I have clearly noted down. If it is not meeting your expected result, if home page does not display, then report it. This is the actual and this is expected. Actual what you are seeing in the application, expected what you are seeing in the test case. Both are not matching. then you have to report it as a bug. That is what the testing team do. Later, when I say testing team completed is testing after 2 years, not 1 or 2 days, okay? If it is a big software. That means we might have tested thousands of times the same functionalities. We will get to know what module will get impact if you change something. But the same mindset will not be there for the developer. Developer will not have the complete idea of the entire software. Whereas testing team has a complete idea because they have tested all functionalities as a team and they understood the complete product. Hence the testing team experts will directly say that this particular build has been released to QA and this has a change in this module. Then I will get to know he has done the changes to this module means it has impact on different modules. I know what are those modules. Based on that, I will create a test suite. Test suite is nothing but the combination of test cases like TC1, TC2, TC3. This is called TS, test suite. The QA manager or a QA lead will create a test suite for the fresh engineers to execute. They might not be understanding what is the impact because I have received a change for this module. This module will have an impact on so and so modules. I have to include those test cases which will actually help me to test what is impacted, not everything, right? Test suite creation. That is, this test suite we execute as part of our regression testing. I hope I am covering more. Regression testing is different part again, where we have thousands of test cases together, we test as a team. Before that, when they deliver a promote or a build to a testing, first we do a smoke testing. This is a very important term and every interview they will ask what is smoke testing, or some people will use sanity testing. Both are important, but intent remains same. Smoke testing or a sanity testing, when, as I said, Unix module subsystem will be delivered to QA as a promote or a build that we need to install. After installation, I have to give an immediate report whether I am going to continue the testing on this build. Is it stable or not? Who is going to confirm that? The testing team has to confirm. I have a certain set of test cases or scenarios. Based on that, I will do my testing. Sanity or smoke testing is what happens if you light some agarbattis here and the smoke will spread across the room. You will feel that what is the smell across the room, right? The same way, I have identified certain important set of cases to be tested whenever they release a new promote to our testing. What for we have identified? To check the stability of the promote. If anybody asks you what is stability or smoke testing, we are going to conduct these two types of testing to check the stability of the given promote or a build for the testing. Stability means it does not have any showstoppers or a blocker issues. I am blocked means I cannot test. That is why, to make sure this particular deliverable which is given by the development in the form of a build, it does not have any blocker issues. Blocker means showstopper. We cannot move ahead is a blocker. I am trying to log in, it is throwing error, it is a blocker. I am trying to click on compose mail, the page is crashed, it is not displaying anything, it is a blocker. So we do sanity testing or smoke testing on a given application to make sure that to test the stability of the given promote for the further testing. Is nothing but smoke or sanity. Sanity means assume that application has a 10 menu. In each menu, one item if I test. That means I am doing little bit of depth testing in the sanity. Smoke means wherever I want, I feel that this is important. It is like a ad hoc monkey testing. I will jump there, I will test, it is working fine. I will jump here and test something, it is working fine. So I will certify this particular promote is good for further testing. So if the build passes in this sanity test or smoke test, we call it as gold build. Understood? Gold build. If it is passed in a sanity or smoke, otherwise it is a scrap build. Scrap means we are not going to accept whatever you are given. It has a lot of bugs, we cannot test further. hence we have rejected it. Gold win, yes, the given promote is looks stable. We are going to do a further testing called regression testing, where we are going to execute around thousands of test cases to make sure everything is working as per customer requirement. This is what we can cover today. I hope it has a lot of information. It should not bounce back. So we are going to stop the session today, and remaining sessions we can cover it later. Whenever we are going to come live, we are going to inform you well in advance, not like today, at least one day before. Thank you all for watching this online. Have a great day.